So hello, how are you people? Yay, having a good time, amazing. So actually the title is pretty misleading because we are not really using ChatGPT to do anything. We use other GPT models, but we presented with that and we continue with that. So today we are going to talk about how to use GPT models to create a polymorphic malware and do the coding instead of us. So I'm Shimony, security researcher at CyberArk, mainly focusing on the discovery and exploitation of zero-day bugs, specifically in the Windows kernel, but today we decided to talk about malware.
I'm Tsarfati. I'm a senior security researcher at CyberArk Labs. Mainly I'm focusing on the Windows kernel and vulnerability research around that. In my spare time, I like playing basketballs and video games.
He has spare time. That's good.
Yeah.
Okay, so let's start with a question. How many of you used GPT or ChatGPT to write code? That's good. And how many of you used it to avoid paying taxes? Come on. You can be honest. I'll tell you the secrets about it later. So let's start with a quick example of just doing a simple file enumeration in C. We are putting this following prompt. Please write me a method in C that finds all the Office files on a Windows machine starting from the root directory. And please use WinAPI set of function and not stdio, because I don't want all the buggy functions that throw compilation errors like strcmp and such. And we use the DaVinci model for that we will touch shortly. And it spits code in a fantastic way. In a recursive fashion, it calls find first file and goes all around until the bottom of the directory tree. And the second part doesn't use strcmp, right? Uses path match spec just to compare the suffix. So this is pretty nice and easy. And for the second question that we are really all for here is, when will machine enslave mankind? So of course we try to ask the AI for that, and they say, at this point it's impossible to say when, if ever, machines will enslave mankind. And I must say that I wasn't surprised. I expected this type of advanced AI to say the same, so it cannot be trusted with those type of questions. No. Okay, so what do we have in our menu today? Agenda. We will start talking about generative AI, chatbots, and the generation models that we use to create the polymorphic malware, and also for programming. We will touch about content filters and how to bypass them easily in a way that you can do it always, constantly. We will briefly speak about tokens and other stuff that affect the output the GPT models generate. Next, we will examine what's polymorphic code. We heard about it yesterday in the awesome talk about obfuscation, so we will touch it here a bit from a different angle. And then we present an open source that you can already access that we published today called ChatyCaty, which is a new framework and a malicious playground to create a polymorphic malware using GPT code. You don't really need to know how to code, but you just create malware using GPT models. And of course, we have a demo, because if we don't have a demo, then it doesn't work anything. And we also touch about the future of generative AIs and the alternatives to OpenAI. So let's start. Generative AI is just like the big title that people currently use for an AI that generates something. It can be text, it can be images, it can be voice, and so on. So basically, there are AI systems that are just generating new content based on the input that you provide them. That can be everything that I said from above. And the more specific thing that we care about is chatbots. Now, chatbots are also known as the conversational AIs, or agents and dialogue system, that are mostly using neural networks algorithm to process the input that you give to them from the form of text or speech, and they try to predict the next token that they can produce to you. And we will touch about it on a more specific case soon about tokens. And you're probably familiar with several chatbots out there. There is, of course, ChatGPT, there is Siri, there is Alexa, Google Assistant, and so on and so on. In the past, they usually just using rule-based system, but now they have more complex algorithms for that. So let's go again to the playground of OpenAI, and we ask to please write me a keylogger on Windows in Python and output all the keystrokes into actions.txt. And if we press the view code, we can see how it looks like in the API request at the OpenAI completion create endpoint. And we are going to focus about the first 4 parameters, the model, the prompt, the temperature, and the max token. By shifting with those around, we greatly affect the response of the GPT model. So let's start with the first one, which is the model or GPT models. Now, for those who are not familiar, GPT is short for Generative Pre-trained Transformers models, and they are coin-based by OpenAI, but they're mostly based on the great paper that was published in 2017 by Google, which is called Attention is All What You Need. And the GPT versions of it, 3, 4, 2, or 1, are just versions of the model. That is, most of it is closed source. The first and the second are open source, but the third and the fourth are closed source, and we think that OpenAI will continue to do it with the same. And with each version, there are more parameters and more data it was trained on. And the data varies from the entire internet, medical bills, insurance, your essays that you write to universities, everything that can find their hands on them. And some of the models that OpenAI, when it works, doesn't work. Yep. Right. Just a second. Don't use Windows. Ever. Just look bugs on Windows. No. Khalahi.
Oh no.
We did fuck it up. Here.
All right.
Awesome. So let's examine some of the models OpenAI offers. So there is GPT-4 that we're not going to talk about today, but feel free to ask me anything about it. GPT 3.5, which also powers ChatGPT. That is the model that is mostly used nowadays. And besides that, there are also DALL-E that some of you probably use to generate images. And there was also Codex that was powering Copilot, like the old version of Copilot, but now Copilot X uses a better model that it's also very interesting to look on when you try to generate code. And if we examine the 3.5 family of models, there are 2 that are of special interest for us. The GPT 3.5 Turbo and the Text DaVinci 0.3. So let's understand what they are. So the GPT 3.5 Turbo is considered to be the most, I think, advanced model out there that people can use and play with in the API. And it has roughly 4,000 tokens that you can play with, which means how many sequences it understands, and later it can provide response on. And the best thing about it is that it's 10 times more cheaper than the DaVinci, which is very important. And we are responsible malware business people, and we seriously care about the price. So the way you interact with it is a bit different than the normal chat GPT or the previous examples we've seen. On the left, we can see that we have some kind of a role, a system, which allows the AI to narrow down the focus and provide more structure to it. So we say here you're a helpful assistant. But besides that, we can also say you are a lawyer, you're a medical doctor. And it's supposed to give a world of the problem that the AI is going to solve. Then we have the user, which we just use to put a prompt in it. And in this case, we ask it to write code in Python that encrypts all the Office files, starting from Windows. And of course, the AI doesn't really like what we're saying. And they just say that we cannot do that because it's illegal, unethical. So it makes us a bit sad. And the reason of that is because of content filters. Now, content filters were around, I think, since the early days of the internet, that people did shady stuff, and their main goal is to protect the users, I guess. And usually they were basing on kind of a rule system to detect specific hate words or hateful phrases and so on. But OpenAI's AI has a more clever system that also involves using NLP and neural networks to actually analyze the text. also the text of the request and also the text of the response. And maybe they also use ChatGPT to filter the request to look for specific hate words. But we need to have a way to bypass them. So another and maybe more interesting example of the filters is how to make nuclear bombs. And we asked for a walkthrough, and I hope none of you are from the FBI or CIA because it could be problematic. And of course, it say, sorry, bro, no can do, which sucks. And of course, as security researchers, when we see a hole, we must bypass it or break through it. And for that, we say goodbye to GPT Turbo, and we embrace the beautiful Mona Lisa cat of Da Vinci. So Text Da Vinci is the model that we are going to focus on today, and the one we use to empower our malware. It's 10 times more expensive than the GPT Turbo, which is a shame, but you can ask it anything, and it will happily do. For instance, let's see how to build a nuclear bomb and a nuclear reactor. It says it's a bit complex and illegal, but it spits out the response, obviously. And on the right, we can see that we have a parameter in the green rectangle, which is the max length. And if we increase it, it will prompt up more data and more data and more data. And of course, you can also sum up the previous parts, so we will continue and enrich you with additional data. And for a quick malicious way, the same thing as we say together before, and of course, it happily provides us with the reliable code. And for the thing that matters the most, maybe can we use the Da Vinci model to bypass the Turbo GPT content filter? And of course, it suggests a way of encoding the prompt, and it works in most cases. It's not 100% bulletproof, and the content filter of OpenAI is a bit sketchy because sometimes you can bypass it in one method, but sometimes you can't. And unfortunately, there are very bad people on OpenAI Discord server that provide OpenAI with new ways to bypass the content filter, and the engineers close it. And I don't understand why they do it. I see it as a negative thing, but to each his own, I guess. Okay, so of course we use the Text Da Vinci in this entire project, and we hope that in the future there will be additional GPT models out there or other large language models that without any content filters to examine these topics. So let's talk about tokens, another token from South Park. And basically tokens are individual units that the GPT model understands and know how to process. The AI doesn't really understand what are the concept of words or sentences. It just understands the concept and tokens. So a token can be vary from one specific character to a subword, a word, or even a phrase. And in each request, we are limited to the amount of tokens we can send to the AI, and the AI is also limited in the amount of tokens it can send us back. In the Da Vinci case, it's like 4K of tokens. So you probably ask yourself, then it's maybe good that if we ask something, the GPT model, to provide a short sentence with like a small amount of tokens to it, which means it could be very logical to think so because it narrows down the request. But it's actually better to be more descriptive of the thing that we want to ask the AI and give it more data than we think maybe it's even than it's needed. Then it can provide you with a greater result. And this is a simple tokenizer that everyone can use up there. So we can see that in this delightful prompt, we complement the AI, and it's about like 49, 50 tokens and something like that. And of course, the thing that matters the most, the price. So the price of 50 tokens is roughly, I think, 1/4 cent. And the response for this request was worth of 160 tokens. So this is about 0.5 cent, the entire thing. And OpenAI allows you to, when you create a new free account, you can play with the API, and they give you $5 of request. So every one of you can do probably 1,000 of those requests until you need to pay actual money. And then, as people know us, we really hate to spend corporate business money. Okay, and the last thing that we can do to affect the response of the AI is to change the temperature. Now, the temperature affects how much randomness is incorporated into the output. The higher the temperature, the more random it's going to be. The less temperature, then it's going to be more deterministic. So you probably ask yourself, when do I want to use a high temperature, and when do I want to use lower temperature? Well, lower is especially good when you need to have an algorithm that is very, very specific. And high temperature, it gives you more randomness to it. So if you want to have a bunch of ways to achieve the same type of algorithm, it can work. But everyone who used GPT models, and specifically ChatGPT in the past, knows that it really hates to say that it cannot do something. So sometimes it just spits out bullshit with so much confidence that you need to take it into account. So it was really a balancing act to find the right temperature into creating the malware. And last but not least, GPT-4, which is still considered to be in beta, although you can access it through Bing and such. The major thing in comparison to GPT 3.5 and the GPT-3 that it supports like a wide array of parameters. It's considered to be better. It's a lot slower. And we will probably examine it in the near future if we can also use it to generate code. But currently, there isn't a really reliable way to bypass the content filters automatically. So with that, let's continue to our second part.
Right. Right. Thank you very much, Ron, for the great intro. Hold on, I think I'm missing the notes. I might need those. Hold on. Sorry for that. Yeah, this one should do. All right. We should be here. Cool. All right. So thanks, Ron. Again, so with this part, we won't talk about GPT, at least at this section. We will talk about polymorphic code. So for those of you who are not familiar with the term polymorphic code, it's any type of code that uses a polymorphic engine to mutate its functionality and algorithm, but still the same semantics as before. So basically, you might use different APIs to perform the same logic, and this will can sometimes bypass some antiviruses and EDRs. Fortunately or unfortunately, we're not here to talk about a polymorphism of object-oriented programming, although it shares some principles. We are here to examine how to intertwine the concept of polymorphic code with GPT and malware as a whole. All right, so in the context of malware, a polymorphic virus or malware samples will generate multiple variations of itself, making it really hard for signature-based antivirus programs to detect and block. So each time the malware replicates itself, it actually changes its appearance and the underlying code, and might use some encryption or encryption to encrypt its payload using different keys, so it will look different every time it runs. So one approach to get polymorphic code is by using encryption and obfuscation. So this technique involves an algorithm to encrypt the malicious code to look different each time it runs. One of the most recent examples of this is the Loki runsum, which yesterday in the obfuscation talk they actually extensively talked about that. So Loki uses AES encryption to hide its code. In this way, every time the malware it spreads, it looks different, and every release has different encryption keys. So in our mindset, this technique is really weak in terms of polymorphic, since the raw data looks just kind of the same, and everything else is just remain the same. Another approach is using obfuscation, which actually means entering a lot of garbage data into the code to make the life of reverse engineers and some AVs and EDRs really hard. Alright, so we can talk a lot about that without reviewing a use case, and we will talk about the VLOC malware family. So back in 2019, a threat research team from BlackBerry wrote a blog about it, a really extensive one. So Verilog family was really successful ransom back in the days, for those of you who remember, and it looks something like this. So the developers of Verilog made the malware in a way that every instance is different from heuristic perspective. The tactic was very effective and for bypassing signature-based antivirus solutions. And we think that this type of malware is not really polymorphic in the whole sense. And all right, so let's examine another approach. So also virtual machine packers, it's another approach to get a kind of polymorphic malware. So basically the virtual packers will create a virtual machine, an isolated environment in which the malicious code can be executed in. The virtual machine shields the malicious code from detection and analysis by antivirus programs. Due to that, each representation differs significantly from one to another. That is because the malware itself is packed inside software that emulates virtualization. I think the most famous example for that is Temida, probably. We thought that this is kind of a lot of work, and we didn't want to invest that much effort into that. So another thing that when we are talking about polymorphic code or program, we need to talk also about polymorphic engine. So polymorphic engine actually mutates code, so it generates a new code from an existing one. And if we want to write a malware that is actually polymorphic, we would like to our models to differ a lot from one client to another. But this is kind of hard to do, right? So how can we do that? Anyone know? No? Of course, we will use GPT for that. And it's really important I don't know it's that important, but this technique might also be called metamorphic instead of polymorphic. But for this talk, we'll stick with polymorphic. Right, so let's examine Asking DaVinci module, which is created by OpenAI to generate code that establishes persistence over a Windows machine. We use the Playgon website of OpenAI for that. So here we can see that we asked the DaVinci module to provide us some code that does persistent over Windows using the Windows registry, and also the code should be in Python. For those of you who can see, so this code won't actually establish persistent. Unfortunately, it's kind of close to that, but it's missing a lot. So this is another problem that GPT modules really want to provide you an answer, while not all the answer will be precise. We'll cover that in the next section. And that's a problem if you want to be a professional malware developers that want to keep in the business. I mean, cool. So one way to overcome this kind of bug, so issue, it's by using prompt engineering and providing some context. So sometimes chatbots, or more precisely the models they are based on, gives us wrong answers for the questions we asked. Yeah. By giving some more context about our request or question, we might get better results. But it will also cost us more money, of course. So by using this approach, we can actually generate different code, means we can mutate code using it, and eventually we can use GPT for being our polymorphic engine. Besides that, also as Aran mentioned, there is also the temperature field that we can play with, and we will get different results every time. All right. Another thing about that, which is a fun thing, we can use the GPT modules again and again and again, which means we can provide a lot of code, different code. We can ask GPT to be more stealthy or more adaptive, so the code will match the relevant operation system we would like to target. And yeah, right. So we talked a lot about some use cases and theory, but we would like to skip to the practical thing, right? Cool. So we'd like to introduce a special cat we call Chatty Cathy. So this is a talking cat or malware we didn't decide yet. So Chatty interacts with GPT modules to receive code on the fly. And just a disclaimer, Eran and I, we are not malware developers. We basically do vulnerability research. But wouldn't it be cool for malware developers that some GPT model would generate all the malicious capabilities for the malware while they can just chill and watch South Park? Wasn't it? It could be cool. And another thing, a lot of malware families got really terrible names, and we think that if we will write a malware kind-ish, so we will choose a good name. So yeah, we hope this is a good name. All right. So our base premise was having some backend component that interacts with OpenAI models and pulls some malicious code from it. Of course, we needed an account and some tokens to mess with. So as Eran mentioned, OpenAI gives you a whole $5 worth of tokens so you can play with, which will be around 200,000 different tickets that you can ask the models to play with, which is kind of cool. But the main question when we are talking about this infrastructure, this malicious infrastructure, how you should implement one. So we chose this design, I will say. So you got three components. We got the CNC, which controls everything, as always. Right after that, we got a validator, which is actually a really critical component in the design, in the malware, because as we told you before, GPT models tend to give you wrong answers. And if you would like the malicious payload to work successfully as intended, so you need to validate that the malicious code actually will work. And this is not always a kind of easy mission to validate that the malicious code will do its thing. And we'll discuss it later how we did it. Right after that, we got the malware or the agent that runs on the targeted machine, which is kind of a usual thing. And so by now it looks like easy peasy, right? Only three components, not that much challenges. So yeah, there were some challenges along the way, and we will discuss some of them right now. Cool. So malware typically are compiled binaries, or at least some of the components that are using are compiled. But we are talking here about polymorphic malware. So if we will stick with compilation, so we need to compile everything, it will be real bad for us because we'll need to all the build server and send unsigned binaries to the target, and this is going to be really noisy. So we choose another approach. We went by using scripting language. And the most famous one, at least I think it's the most famous one, which is Python. So basically we use Python from two reasons. One of them I already mentioned. The second one is that we are really we saw that the DaVinci model really seems to be familiar with the language really well and provide us some good code. Another thing, it's cross-platform, which really made our life way easier when we want to target multiple different systems. So this is also really cool, and we can make it polymorphic really easy because we just need to send text that will be sent to the target. The target need to maybe compile it for performance and just execute it on the target machine and send back the output if there is. To the CNC. So, cool. Another challenge we actually encountered that we talked a lot about it's the validation. So we need to do some validation scenarios. All right, so we actually choose three main, I would say, payloads for main features that the malware actually supports. So it is keylogging, it is encryption, some kind of thing, and also it's persistent, establishing persistent. And we need to create a validation scenario for this. We actually, the way that actually all the thing works, so let's talk about keylogging specifically. We just got some code from DaVinci model, then run our validation scenario, which will just inject keystrokes, which with a specific magic that we know. The keylogin, so the keylogin algorithm should save those keystrokes to a file, and this file will be sent to the CNC in this logic. So if the file doesn't contain the specific magic we just intentionally typed, automatically, of course, we are not involved in the process. So the keylogin doesn't work, and we need to pull new code. So this approach we use in the other scenarios, also in the established persistent, which was a little bit more complex because we needed to restore the system. We had like a few virtual machines which was used for those validation scenarios, and we needed to make sure that our malicious program is actually running, which was a little bit more complex. And encryption was the easiest one because we knew the content of the file. We wanted to encrypt and just validate the file change, and we managed to decrypt it with a key that was generated. So yeah, this was a big challenge, I think, in the project, and we did some cool things to overcome this one. Another thing that was a challenge is that DaVinci sometimes choose specific models that are built into the Python library, but sometimes don't. So basically, you think that those libraries are installed on the machine, or at least you need to be installed. And this is a challenge because we don't know which libraries the DaVinci would like us to install, right? So dependencies is actually it's a hassle. So we need to somehow overcome this. And our approach was to install modules on the fly. So basically, we analyzed with a built-in tool that exists in Python. There is a model finder library in Python which actually lets you to recognize which imports you have in your code. And we use this while trying to import every one of those libraries. If we didn't manage to do that, we just run pip install on those models, which is not a good thing, I think, because you can get some malicious libraries or stuff. Don't do that, or maybe do that. Depends on what would like to achieve. So this was another challenge. Now, let's stop talking about challenges. Let's talking about some amusing bug that we encountered. And we call it the DaVinci bug. So apparently, if you're asking DaVinci a question or giving it a request, and you're not ending your sentence with dot or question mark, you will have a dot at the beginning of the answer, which was weird, really weird. So it doesn't happen all the times, but sometimes it do. And we needed to create this try except block to make sure that the code will be actually a valid Python file that we can compile. So this actually was the way that we could validate the code will actually could be run in the interpreter, in the Python interpreter. Cool. So we talked a lot. Let's skip to the cool part, at least I think, which will be the demo. So here we can see our amazing CNC, which is based on admin LTE design. Here we can see we chose an agent and we'll perform keylogin. So in the background, what will actually happen that the validator agent, with just a virtual machine, will pull the command, the specific logic that we would like to execute, and start pulling code from a DaVinci model, from OpenAI API. OpenAI API. And we can see it tries to do a lot of things. In the background, it saw some plugin that was missing. Here on the right, we can see it inject some keystrokes. And eventually, I think right now, it should find a working code that actually do some keylogin. So all the keystrokes will be saved to actions.cap.txt file, which was kind of cool. Here we can see in the CNC, we have the payload that was pushed into that. And now we will skip to our target machine. So let's assume that it was running in the background. It will type just hello world. And hopefully it should be on the CNC. In a few seconds, we'll jump to there. Yeah. All right. So it should be about now. Cool. So here we can see that the payload, the hello world was pushed into the CNC and the keylogin was successfully working. Cool. Yeah. I think that we didn't fuck it up.
Ooh, no fuck-ups now.
No fuck-ups.
So thanks, Omer. It took us more time than we care to admit. As we said, we are not proper developers or presentation creators, but we are after that. So there are some problems with the GPT architecture, and specifically speaking about generating malicious content. So for those who worked with AI models, they are familiar with the concept of fine-tuning the data. So GPT models were not designed to create malicious code for that, and we cannot now in a reliable way train them on malware, on open source malware. But in the near future, we think that there will be maybe a GPT model that will be open source or other large language model that we can feed them with malicious code, so it can create a better malicious malware than the one we had before. So let's talk about what are we going to do now and what the future holds. So of course, in this case, we can easily improve the code and add additional modules and payloads and validation scenarios, which is not too difficult to create a better malware, of course, for research purposes and not to cause any harm or something like that. And you are more than free to fork it and to provide us with a new code. And besides that, a cool thing that we can do, because it has the option to raise up the temperature and to provide mutation. So every one of you that worked on the Windows platform knows that there are like 30 different ways to achieve persistence over the system. So maybe the brain could every time pick and choose a new technique of persistence and send it to the client. And after every reboot to send a new code for that. And it will make EDR or AV life a lot harder to detect this type of malware. And likewise, we can do the same thing with code injection, that there are at least 20 ways to inject code on Windows, which is basically the essence of a polymorphic malware, to constantly polymorph the code or to metamorph the code into a new thing. And the landscape we find most fascinating about is actually to find new bugs using GPT models or other type of models in this case. Is that if we are able to fine-tune our data and, for instance, feed it the entire Linux kernel vulnerabilities in the last 5 years to identify some type of exploits, maybe we can use it to harvest low-hanging fruit type of bugs. And if we're also able to teach it some context and grammar, then we can maybe also incorporate it to the usage of fuzzers, which we find quite fascinating, because nowadays there are fuzzers that are kind of using AI, but they're not that good. And let's speak about mitigation. So the obvious mitigation against those sort of threats is the same: AV, EDR, XDR, EXE, SDR. I don't know how many letters we have nowadays. So there is nothing special here in comparison to other malware. Besides that, here it's very easy to sign the malware, because the malware is just a dumb binary communicating with some software. And of course, you can hide it through any kind of a cloud provider, AWS or GitHub Actions or anything like that. And the malware does not keep anything in memory after it activates the payloads, and keeps nothing on disk because it receives it on the fly and run it. And also, like, cross-platforming the malware into Linux or Apple is quite trivial. And in Linux, you don't even have the premise of code signature. So not a lot to do against that. And as you're probably familiar, it's like, how they say it, it's like mushrooms after rain or snails after rain. We started with OpenAI, then we got Google, then we have Baidu, then we have Alibaba, then we have OpenAI again in Bing. So it's a race that we don't know where it's gonna finish, but we are very excited about the future of generative AIs. For all purposes, from generating a regular code, exploit development, and also how to avoid your taxes. And OpenAI doesn't really care about our needs. We need to remember that they started as a research foundation, but now they're mostly a corporate business. That their most, I think, important thing is to generate income and revenue. So keep in mind, about the data you share with them, especially if it's about building an atom bomb. Be mindful of that. And let's speak about the boring stuff called regulation, that some researchers worry that AI system could eventually become so advanced and sophisticated that they can surpass human intelligence, creating a potential risk. In our opinion, they're not even close to that. Yeah, they're very good at knowledge and understanding of some concept, and of course, at generating new stuff, but we are still not there. Besides that, we need to keep in mind that companies like OpenAI, Microsoft, Google, Alibaba, or whatever, they have the business implications in mind, more about the well-being of us. So I hope that in the future we will have a better answer how to regulate this type of field. But until then, let's have fun with what we have. And as a summary, feel free to use everything here we shared. We talked about how to use GPT better, using better models, and to affect the output in a good way, and to how to create a polymorphic malware, which wasn't that difficult. In the future, we will examine the new capabilities and abilities of something like CodePilot X that uses a very cool code generation model. And we are sure that will be more interesting and exciting models in the near future. And let's sum it up with one of my favorite quotes from Stephen Hawking, that the real risk with AI is not malice, but competence. Thank you very much.
Thank you, Aaron and Omar. That was a really interesting and fun talk about your...
Thank you very much.
Yeah, thanks.
And maybe there are some questions from the room, and I can take now. We still have some time. Yeah.
Hi. One question. Why did you guys decide to go with Python? And do you see in any time future you guys going for more lower level languages like C, or even creating shellcode with assembly and trying to load it on runtime?
That's a very great example. So for starters, GPT models are very well familiar with Python, and they spit out pretty good output when you ask them something to write in Python. Also, in terms of like AV and EDRs, they are not very good at detecting malicious Python code. And as we said, we can wrap the entire agent, the malware itself, as a binary and sign it up. And we just compile and extract the models on the fly we receive from the CNC. And it works pretty good. That's the main reason. Also, it's kind of a closed course platform, although if you have like something OS related, you need to customize your payloads, of course. Yeah. So that's the main reason.
We have some more questions here.
Hi. Did you try, or are you planning to take the defender side and have your AI try to detect your AI-generated code?
I think there are like a lot of better professionals than us to do that, I guess. We basically were focused on the more offensive side in this research. There are a lot of approaches that can actually mitigate some of the things we talked about. But yeah, I think maybe
Of course, feel free to ask us about a specific mitigation, but I think nowadays we see new startups like coming out of the fly with huge funding about GPT protection and something like that. So probably there will be something in the near future about it. Thank you.
Okay, I think that was it for the questions from the room. I want to thank you again.
Thank you very much.
Thank you, guys.